Hey everybody, this is Crow's programming course and we are creating Brickbreaker today. Here's a quick preview of it. You're going to have a ball that bounces off the slider, and as you can tell, depending on the angle at which you're hitting the ball off the slider, it will bounce differently. And so if you hit the bricks, they will disappear. If you hit the side or bottom of the bricks, it can bounce off multiple times. We do a really basic, and I make it so I can't lose there, and then you have a you win screen. So let's go ahead and get started. Okay, to start off, I'm going to make my size of my world a little bit larger. And I'm going to add in an actor. And this actor is going to be my player. And they are not going to have an image quite yet. We're going to go ahead and open editor, and we're going to create an image for it. So we are going to create a constructor for it. So public player. And there's a way to construct your own image. If you do get image dot and then do control space, you will see a list of different methods that are available in the image class. And we are going to first set the color of our object that we want. You have to set the color first. And you can access the color class by doing color dot and the color in all caps that you want to use going forward. Then you can access the get image class once again and do control space, and you can fill a rectangle, and this X and Y value is the starting point of which you want your image. And so we want a 0, 0. That just means it starts the fill at the upper left, so right at the top left corner of where the image starts. And then we will have our player be 100 by 20. And then with just doing that, you're not going to get your full image. We want it to be about 100. And so this is the default size of an image that is not given. And so we want to change and set our image. And in the newer versions of Greenfoot, you are able to create a new image. And we will create it 100 by 20. And call it player. And now, if we reset and throw a player in the world, we have our player. Okay, so now let's check the location of the Y that we want the player to be moving at. It's about 550. So we will go in and create a prepare method to tell the world that we will be preparing with this method, and we will do player equals new player. So this is defining the class that we are about to name, and we name it just lowercase player, and it's going to be one instance of player. Okay, and then we will add object player, and the location is at 550. Excuse me, it's at the middle of the world, which is 300, 550. Then we call that method in. And we have our player in there. Okay, so let's make our background. And we can, and similarly to the get image, we can do get background and control space, and we can fill that background with a color. So we need to set color to color.black. And then we need to get background dot fill. And that will fill it with the color black. Okay. Then we need to create our blocks class. And inside of our blocks class, we're going to do something similar to how we drew the player. We will do get image dot set color dot blue, get image dot fill rectangle, and we'll go 0, 0, and we will have this be 60 by 20. Now once again we need to set the image of our block here by creating a new image and have it be 60 by 20. Call it block. Okay, and if that's the size we want, you can always adjust it for what you guys want, but looks good to me. Let's make sure we set the image to the block image. Then when we add it in, this is what our block will look like. And so we know that our world is 600 by 600. And so when we design how our background wants to be, we can do what we call a nested loop. So the first loop will be the width of the world, and the second loop will be the the width of the number of blocks across we want. And the second loop will be the depth and the number of blocks tall we want it. So I equals 0, I less than 6, we'll get us 6 of them. 8. That'll get us 8 of them. I plus plus. And then inside of that loop, we're going to have our height. We'll call it J. J less than 4. J plus plus. And then we can do add object. And since this is not just one player that we're naming like we do up here, these are just going to be all the blocks. We can just add a new block instance, and then the X and the Y value. Okay, so this is the X value we're going to do is 30 to give us half a block of space along the X to move over. And then we're going to add to that. So we'll start off, our very first row will be 30 over from the edge, so it's not right up against the edge. And then 60 times I, that will give us 8 of 60 across. And then our Y value will be, we can do 20 times J. And let's just see how that looks. We can edit it afterwards. Okay, so they're too close together. Now they're right next to each other. So we want to give it a little bit more than just, because this is exactly perfectly filled. So we don't want that. We want it to be a little bit more. So we can do 70 and 30. That'll give us 10 pixels apart, both with width and height. Okay, and then half. So the block can be all the way, half of the image can be inside of the wall, and we don't want that, so we want to make it a full block over. So we'll do 60, and that's a lot better. Okay, so now we have our bricks set up. And then we want to create our ball class, and we want to create an object for our ball. And just, this is a fairly small ball object that will work for us. Yeah, that looks good. Okay, and we can put it in our ball. We can put, and since these are just one lines, you don't need the curly brackets to encapsulate it. Okay, with one line if statements or one line loops, you can just do one command without curly brackets. So we can do ball equals new ball. Since we only have one ball that we are going to declare, might as well name it so that we can manipulate it if we need to. And we can do add object ball, and we can put it at, well, if the player is at 300, 550, we can do 300, 450, and our ball will end up right here. Okay, so let's have our ball move. I'm going to do a move around because we already have a move method that's in the actor class. I just don't want to name it the same thing as what the move method is in our actor class. So we can go say that our location will be get the current x value. Then we're going to need to add something to it. And when we're using physics, the distance away from the current x is what dx is, and it's good to use. It's commonly used in programming, and dy. Okay, and so this is not defined yet. We need to make sure we have int dy, and we can set that equal to a number to set the speed so far going up and down. And then int dx equals 0. Right now we don't want it to move. So now we can put this move around code into our act method, and we will watch the ball move down. Okay, but we also need it to bounce. And so if is touching player.class, what do we want to have happen? Well, we want our dy to go the opposite direction. So you can just do dy equals negative dy, and then you put that in the act method. So once it bounces, you also want it to bounce off the bricks. So these pipes, they call them, if you hold shift down and you go between the backspace and the enter, there are these pipes that you can create, so you got to hold shift down to create them. And then you do is touching block.class. We will have them also bounce there. So now you have them bounce back and forth. And there's a little bit of space. If we change our ball, I believe there's a better ball in there that you can use that might actually physically touch him. So I'm going to go ahead and do that, and I'm actually going to make my ball make a constructor because I want to change how it looks, and I want to make it a little bit smaller. So I'm going to go ahead and scale it down. So I'm going to do get image dot scale, and I'm going to just go ahead and get width. I'm going to get the image's width, so get image dot get width divided by 2. I'm going to get image dot get height divided by 2 and see what that does for us. Make it a little bit smaller. Perfect. Now we got a ball bouncing back and forth, but as you can see, it just bounces straight up and straight down. We don't want that to happen, so we are going to have to detect where the ball is, and then we're going to have to make the ball based off where it hits both the player or the block. It needs to bounce in a different way. I'm going to focus on the player. The ball, depending on where it hits the player, needs to bounce at a different angle. So we're going to need to do something a little bit different with that. So we're going to need to have the ball detect where it's hitting on the player. So in order to do that, we need to be able to see the ball, be able to see both the world, the my world, and see if it can detect this player that we have defined in the my world. Okay, so I need to move it from being local to just the prepare method and make it so that it's local for the entire class. And to do that, you need to move this outside of the prepare method, and you need to make it public. So that's the first thing you need to do. Then you need to go to ball, and inside the constructor, you need to say, hey, I'm going to pass this player, a specific player, onto you. Okay. Now this is passing the player to the ball. But if you guys can imagine, in order for the ball to be able to receive the player, you need to say public player. So this allows the ball to be able to see the player class, depending on what player we're sending it. Okay, and we're sending it whatever player gets put into the parameter right here. Okay, and so we're going to have this dot player, which is specifying the player that we have defined right here. And we're going to say it's equal to player, and the player that's right here is the one that's getting passed in. So this player is going to be equal to this one. Okay? And so now we're going to have an error because our ball requires a parameter that is called player. But now, in order for the ball to be able to see this specific player, it's also going to need to be able to read which world we're using. And we're using just the only one we have, the my world. So we need to make the my world available. So we're going to say it's of the class world, and we can call it my world. Okay, and we do not need to define that. It's not a new instance, it is just the my world that we're talking about. Okay, and so when we pass that in, we can actually just call it this, and we actually don't need to call it in because it knows that it's referencing, well, what is it referencing? Oh, it's this instance. The this keyword is referencing the instance of whatever class we're in, and right now we're in the my world class. So that one instance of my world that we're using. Okay, and so when we go back into ball, that's where we need to make it visible for our ball to be able to see a world. So let's call it my world so we know exactly what it is. And then we need to create another field for this, and that will be world. And we can call it world or my world. It doesn't really matter what we call it, because we're definitely going to pass that in, but we want to set my world equal to our world. So my world equals this name of world. So then when we go back into my world, this needs to make sure that we know now it is fixed, the error is fixed because it knows that it is going to be this world we're referencing. So now we need to go back into bounce, and we need to say, and we're going to kind of test this real quick. We're going to say and, so it's this or this and something else. Okay, so we're going to go make sure it's put extra parentheses around here to make sure it's player or block. That's one condition right here. And then also and another condition. Well, this dot player, which is equal to whatever player we passed in, which we've already told the ball which player we're passing in. And we're going to say if their x value is less than the x value of the ball. And no semicolon there. And make sure you have the right number of parentheses here. Okay, so now it's saying that not only does it have to be touching a player or a block, but it also needs to be, the player needs to be less than, the player's x value needs to be less than the ball's x value. So let's go ahead and test this right now. So if I make my player's x value greater than the ball should pass through it. And this is just a test. Okay, and it does. But if it's less than, it should bounce, and it does. Okay? And so now we know that we can do something specific. If it's on this side, it'll hit it. If it's on this side, it won't. But instead of just saying that will either hit it or it won't, you need to go back into ball. You need to make a range for it, for the player. So if the player's X value is less than the ball's X value plus 5, well, let's just do plus 50. So if we do this, the player's X value will be 348. So if the ball's X value, if you could imagine adding 50 to that, the player will still be less than the ball plus 50, because the ball right now is at 300 and the player's at 348. So the ball at 300, it will add 50 to that, and so the player will still be less, so it still should bounce. But that is how we get the left side of our object here, is by adding 50 to it. So now we know this is the very far left side of the player. What do we want to have happen if it hits the very far left side? Well, we are going to have dx go left if it hits the very far left side, so we can do a minus equals 6. And then let's see if we can make that happen for us. So if it's very far left, you can see it bounce far off to the left at a sharp angle. Okay, so that's if you hit the very far left side. Sorry, if you make it get x greater than plus 50, that means the player, even if the ball is over here, you need to imagine it right down the middle, or even a little bit further over, so that the player is still greater than 50 plus on the x. So if the player is still greater than 50 plus on the x, it'll bounce to the left. And then if you copy that and then paste and say else otherwise, if the player is less than minus 50, and then you change this to a plus, it should bounce the opposite way because we made everything the opposite there. So now, if we let it go right down the middle, it won't do anything because it's not on the left or the right. So now we're on the right side. And now we can get the left side as well. So now we have our left and our right. And then we can copy this, paste 2 more to start at least. And then we know that this first one needs to be greater than get x minus, not minus. We're going back and we're basically copying this first one at a lesser degree. So we're going to do plus 40. And we're going to change this 6 to a 5. So if it hits at the 40 spot, just inside 10 pixels inside of it, then it will bounce a little bit less. And then this minus 50 needs to change to a 40, and it's going to stay less than, just like this one is less than minus 50. And instead of this one is plus equals 6, make sure this one is minus equals 5, and this one should be plus equals 5. And so let's see what it looks like if we make it pretty much on the edge, but not quite. Okay, so that should be not quite as sharp of a turn. And so that's not quite all the way at the 40 spot, neither is that. Let's measure it and make sure we're within that 40 to 50, 40 to 49 range. Okay, so this is 261, and this is 300. So we're going to need it over just a little bit more. Let's test it. We want to make sure we have it all right. 257. So that's 43 pixels over. So this one should bounce to the right, not quite as sharply. Okay, and then let's see if it's all the way over, how sharp that is. Okay, so that is more sharp, and we can always test this by changing this one. This is the right to 10 to really make sure that we know that it's working. So we make sure we know that it's working for sure. Okay, so if we hit the edge here, it's going to go way right. And if we hit, it doesn't go quite as far to the right. Okay, and so we can keep doing that as we go down. Now that we have this in there, and then we're going to change this to 30. And we are going to go ahead and change this to 4. And since we had both of these correctly with the correct symbol, less than right here, greater than right here, and the plus and the minus, we don't need to change any of that on this next one. We just need to change the numbers on this next two. So we can change this to 20 and 20 and 3 and 3. We can paste. And we can change this to 10, 10, and then 2, and 2. And then we can say paste one more, but actually we can get rid of this bottom one because we're just going to say otherwise if you're hitting one of them. If it's not along that, the last option should be just the DX does not change. So if you hit it right pretty much in the middle, inside of that 10, 0 to 9 or 0 to -9, it should just bounce straight back up. And so we can test that in a multitude of ways. So if it goes straight down, it should bounce straight up, and it does. But if we move it, it should glance off to the side. And I'm not sure if I showed you guys, but I went ahead and I created 2 if statements to move this player left and right. So if you haven't done that yet, you didn't see me do that, go ahead and test that and go ahead and go into the player and add in these 2 if statements. That'll just slide it to the left and slide it to the right a little bit. So now we should see, and it'll glance off since we're on the blocks as well. Since we did blocks and the ball, it should glance off both of them since we're block or the ball. So I've realized a slight problem that we have, and so we are not going to be able to do the or here because this is going to first we want to change this back to 6. But we do not want to do the or either because it is going to base what our player is, where our player is at when we hit the block. And so we do not want that to happen. So we need to erase all of these. Sorry, I know that that takes a little bit of time, but you do not actually need that extra parentheses either anymore because we're going to get rid of all of this. So go ahead and do that now. And then you can leave in this last else if it's touching the player or the block. It's just going to bounce and it's not going to check. It's not going to change the X. Okay, and so let's see how that works for us here. So now when we move it, it shouldn't change the X value at all. Okay, and so let's make the ball bounce on the edge as well, and you can clean it up later and turn it into a switch statement a little bit later. or have it be a nested if would probably be best. Just have it be if it's touching the player, and then within that, if this is true, and then and then on the next if statement, a separate if statement within the is touching nested if. We can clean that up here in a bit, but first we're going to leave it like that. So go ahead and create a new method, and we're going to do public void bounce off edge. And so we need to say if our x value of our ball is greater than or equal to the world, so get world.getWidth open close parentheses -1, we are going to have our dx equal negative dx, and so that'll just bounce it off the wall. And then you can copy that, and you actually don't need the parentheses since it's one line, and then you're going to do if it's less than or equal to 0, it'll bounce off the edge. Put that in the act method. Bounce off edge. Now it will bounce off the edge. And now we're getting close. We're getting there. Okay, and so yeah, we're gonna need to fix it getting stuck in there. Okay, so now we're going to need to create a method that has our ball void hit block. And so we're going to say if our block, if is touching block.class, we are going to, so we can't do an is touching because we're going to need to remove one block object. We can't have it remove all the blocks in the code. So we're going to need to be able to access one specific block. And so we need to create a way that we can see one specific block, but we don't know which block it is. So there's an actual method that we can do to find which block we want to get rid of and which block we actually are hitting. And so you can just call an actor and name it block and say it equals get one intersecting object of the block dot class. So this will check if anything is intersecting the ball of the block class, and if it is, we're going to turn it into one single actor object. Okay, and if that one single actor object is there or not equal to nothing, not equal to null, then we are going to get world, and we are going to remove an object in the world. Remove object. And that one object we're going to remove is that block that we just found. Okay, so if we do it in the act method, I'll show you guys. There is a little bit of an issue. We just put it in the act method. So at first it looks like it works out great, but over time you might notice that there are some issues with it if you hit an edge or get it stuck somewhere. So as you can see there, if it hits the side, we have some major issues. So if you leave the hit block method like this, oftentimes it'll hit the block from the side and it'll just bounce because it is touching block.class. So we'll make it go back down, but if it gets caught behind, it'll knock out 4, 5, 6, 7 blocks at once, and we don't want to have that happen. So we're going to steal the code that we used up here for seeing where the block is and we have already found if the block is intersecting, and so we've already found that object. So we can actually steal this getOneIntersectingObject method that we've used, and we can say, and if block.getX is greater than, getX of the ball plus 30, since it's 60 wide total, this will be the side of it. And we will have that'll mean that it's hitting the side of the block or the corner, but more likely the side, and we'll have it go the opposite direction of the X value, horizontally go the opposite direction. So we can copy and paste, flip the symbol, change it from positive 30 to negative 30, and it'll go the opposite way of the original X value. And we want to do this or this, else if this. Otherwise, if just regular block is not either of those, not on either side, we will simply get world.remove object block and not change the DX at all. Okay, and so if we compile this, make sure it's in your act method, and you run this, okay, starting off, everything's good. It hits the corner, and it doesn't go through, doesn't bust through on the corner, and even if it hits the side, completely the side like that, it will just bounce off. And even if it gets stuck, that's part of the gameplay, is if it does, you do want it, if you do hit a good shot on the side, you do want it to be able to get stuck in there eventually, but you also want to be able to control that. So what I want to do now is I'm going to go ahead and create a you lose screen. So if I'm going to do public void you lose, and I'm just going to do a simple one. You guys can go a little bit more crazy if you want, but if get y is greater than or equal to get world.getHeight -1, just to give it a little bit of room, we will do just a simple Greenfoot.stop. If you guys want to go to a different game and find a you lose screen and do a get world.add object you lose, you can add in a you lose screen. And so if we actually put the you lose in the act method, we can test that. And we can slide this over. Okay, and Greenfoot stopped. I know the run button does not work. It goes from stop to start and start to stop if the you lose is correct, so it is correct. Okay, and then if it hits the top, we can add this to the bounce at edge. If get y is less than or equal to 0, we actually don't need the curly brackets. We can do dy equals negative dy. So it flips our y path, so that if the ball gets stuck back here, we're bouncing. Okay. All right. Now we have to find a way to win, and so we need to create a counter. Int count equals 0 to start, and we will do a count ++ every time an object is removed. So we'll do count ++ here, count ++ here, and add curly brackets to this one, and do count ++ here. Okay, and then we'll do the you win screen, public void you win, say if count equals it is I believe 8 by 4, so that'd be 32. We can do get world dot show text you win, comma, get world get width to put in the middle divided by 2, get world dot get height divided by 2. Okay, and we can test that by changing that to we can just put it to 1 for now. Add it in the you win. And we can test it. You win. We need a Greenfoot dot stop to end the game. So after we add it in, we can do Greenfoot dot stop. And then that will work. And then we can check with 32. I'll speed through it and you guys can watch me try to win. And I'm going to actually take out the hit bottom, the you lose, so you can't lose. So I'll comment out you lose, make it a little easier on myself, and I'll cheat my way to win, and I'll add in if get y is greater than or equal to get world dot get height minus 1. We will just flip it, the y value, and so now we really can't lose and can't get it stuck. And I'll quickly go through this and I'll show you how to win the game. See how I do. Sweet. Now I won the game. Hope you guys enjoyed Brickbreaker. This is the Crow Code signing off.